Her lines were sleek and powerful. She was designed to kill, to seek out and destroy an enemy bomber. She was the most advanced, the most sophisticated weapon of war conceived and built in Canada. She was the Arrow.
The Avro Arrow is one of the greatest inventions and creations in Canadian history. The Avro Arrow was a delta-winged interceptor aircraft. The aircraft was made by the Canadian aircraft plant called Avro Canada, and in 1945 this company was the third largest company in Canada. The Arrow was intended to be used by the Royal Canadian Air Force due to its amazing feat of reaching an altitude of 60,000 feet. The production of the Avro Arrow started in the 1950s with the studies of a series of designs. Over the years, many variations of the Arrow were made and improved on. The first version was the CF-100 Canuck, which is the inspiration for the whole project and the basis for the upgraded arrows. Over these couple of years, many different models and designs were made for the new arrows to upgrade on their original. Finally, the last make was called the CF-105, marked as RL-201. This means the plane was called the CF-105, but each plane has a code, and the first CF-105 made was the RL-201. It was shown to the public on October 4th, 1957, the same day as the launch of the Sputnik 1. The first testing of the Arrow started with the first make, the RL-201, on March 25th, 1958. And with the test flight, the aircraft quickly proved and demonstrated excellent handling and overall performance, reaching Mach 1.9 in a level of flight. Because of the success of this test, another 3 CF-105s were completed. RL-202 through to 204 were made. Now, Avro Canada was ready for the lighter and more powerful designs and were ready to start designing. Then, on the 20th of February 1959, one of the biggest conundrums in Canadian history took place. The overall Arrow project was abruptly halted before the project review had taken place. Then, 2 months later, all of the assembly line, tooling, plans, existing airframes, and engines were ordered to be destroyed. The subject of the cancellation of the Arrow has been a topic for years, and has been discussed by historians and scientists alike. The cancellation put the Avro Arrow out of business, and the jet has never been remade to this day. The idea of the Avro Arrow fighter jet was because just before World War I, the Soviet Union started making a fleet of long-range bombers with the ability to deliver nuclear weapons across North America and Europe. One of the big threats of this was the high speed and high altitude these bomber jets could reach. This is because they could fly over Canada and the US with enough speed and altitude that they could drop their bombs and we wouldn't be able to stop them until they were right over us. The goal was to engage and destroy these bombers before they reached their target. Then, the next year, Avro Canada began the design of Canada's first fighter jet for the Royal Canadian Air Force, or RCAF. This jet was called Avro CF-100 Canuck, an all-weather interceptor and the main inspiration and base for the Avro Arrows to come. The Canuck went through a lengthy and troubled prototype stage before entering service 7 years later in 1953. Nevertheless, it went on to become one of the most enduring aircrafts of its class. serving a variety of roles until 1981. Because of the delay in the production of the CF-100 and the fact that the Soviets were working on newer jet-powered bombers, this rendered the CF-100 ineffective, and the Royal Canadian Air Force submitted designs for a new fighter jet that was more effective than the CF-100. The new Avro Arrow engineering was considering supersonic flight. Supersonic flight is one of the four speeds of flight. There are subsonic, transonic, supersonic, and hypersonic. Vehicles that can fly at supersonic speeds are flying quite faster than the speed of sound. This new design presented a ton of new problems. One of the new supersonic flight design problems was the form of new drags, also known as a wave drag. The effects of the wave drag were so strong that the engines of the air could not provide enough power to overcome it. This led to the new concept known as the sound barrier. Then, during the Second World War, German research discovered the onset of the wave drag. They discovered that the wave drag was greatly reduced by using airfoils that varied the curvature in the wing of the jet as gradual as possible. This meant the design of the new supersonic plane would need to use thinner airfoils with much longer chord. This is not what the designers would have used on the supersonic aircraft, so they had to change their design. These designs were also impractical because they left little internal room in the wing for fuel. With these new designs, the concept was immediately applied. This started in the late 1940s. Avro engineers used the design of the original CF-100 and started modifying it. The new model was known as the CF-103. The CF-103 offered improved transonic performance with supersonic abilities in a dive. However, the basic CF-100 continued to improve through this period, and the advantages of the CF-103 died down. When the CF-100 broke the sound barrier in a testing on the 18th of December 1952, the interest in the CF-103 was dropped. After this, there was another solution to the high-speed problem. The new idea was the delta wings. These provided more room for fuel, and there was an important consideration given to the insufficient early jet engines of the era. Also, the large wing provided ample lift at high altitudes. The delta wing also enabled slower landings. There were some disadvantages though. The new wings increased drag at lower speeds and altitudes, and especially higher drag when maneuvering. The delta wings and the insuccess of the CF-103 resulted in a new version of the Arrow design. They were known as the CF-104s. There were two versions designed, a single-engine C-104/4 and a twin-engined C-104/2. The designs were otherwise similar, using low-mounted delta wings. The advantages of the C-104/2 were a larger overall size, which offered a larger initial weapons bay. The proposals were submitted to RCAF in June 1952. After these submissions, there were major discussions between Avro and RCAF. They examined and modified the designs. There were a wide range of changes. This was on April 1953. They designed the new model specifically for a crew of two with twin engines. For a cruising speed, it was designed to go as fast as Mach 1.5 and could reach an altitude of 70,000 feet. Avro submitted their new models on May 1953, essentially a two-man version of the C-104/2, with a couple engine modifications. The new design also allowed the wing to be built as a single structure, sitting on the upper fuselage, simplifying construction and improving strength. The primary engine was a Rolls-Royce RB-106, which offered around 21,000 pounds of force. It was also designed so a wide variety of weapons could be deployed from the bay of the jet. One of these weapons comprised of a Hughes Falcon, which is a guided missile. This missile was the equivalent of a 1,000-pound bomb. In July 1953, the proposal of a new model was accepted and Avro was given the go-ahead to start a full design. It was given a name after all of these changes. It was now called the CF-105, marked as RL-201. Then in December, $27 million were provided to start flight modeling. Then in March 1955, the contract was upgraded to $260 million. In the normal production of a plane or jet, there are a small number of prototypes of the aircraft that are hand-built and flown to find problems. The production system that the CF-105 took was called the Cook-Craig system. The starting of this system was the building of a small number of aircrafts that were models of the jet they were building. These were built as production models. Any changes that would be made would be incorporated during the testing of these models and then continued. Experiments showed that they only needed a small number of design changes, mainly involving the wings. After this stage, production was in full swing and the test program was complete. By the mid-1954, the first production drawings were issued and work began, along with an extensive computer simulation carried out by both Canada and the United States using sophisticated computer programs. Then on October 4th, 1957, after many changes and designs and testing, the newest and final make of the Arrow was produced, the CF-105, marked as RL-201. They released the news to the public at this time. They had planned to capitalize on the event by inviting more than 13,000 guests to the occasion. Unfortunately for the Avro Arrow, it lost a lot of attention because of the Russians' launch of the Sputnik the same day. The Sputnik was a Russian satellite that was capable of shooting bombs at the Earth from space. The new Avro Arrow was first tested on March 25, 1958 by the Chief of Development and Test Pilot Janusz Zarkowski. The point of test flights were to prove a plane's limits and to assess flight characteristics and to reveal serious design faults. The CF-105 demonstrated excellent handling throughout the test flight. Then on its third test, the Arrow went supersonic, and then on the seventh, it broke 1,000 miles per hour at 50,000 feet, and it was still climbing. The CF-105 at top speeds could reach Mach 1.98. This was not at the end of its limits. This is a speed nearly 3 times the speed of sound. During the test, there were no more major problems encountered. There were some minor issues with the landing gear and flight control system that had to be fixed. But there were some issues that didn't just come from the technical aspect. Around 1953, some senior Canadian military officials began to question the program. They thought that the Army and Navy were both being strongly opposed by the Arrow. This is because they claimed that the money that should be used on the Army and the Navy were being used for the production of the Avro Arrow. Then, on June 1957, the Liberals lost the federal election, and the Conservative government, led by John Diefenbaker, took power. This new government had different prospects than the Liberal government, and that's when things began to change. Diefenbaker did not agree with the way the Liberals had been spending money on the Arrow project. Another problem arose on August 1957 when Diefenbaker and the new Conservative government signed the NORAD, which stands for the North American Air Defense. This was an agreement with the United States making Canada a partner with America's command and control systems. The States Air Force, or the USAF, was in the process of completely upgrading their air defense systems with the SAGE project. The states offered Canada the opportunity to share this sensitive information in return for North America's air defense system. One of the SAGE project's main aspects was to defend against manned missiles. Then, the Canadian government also decided that the defense against ballistic missiles was becoming a priority. This is because the Russian Sputnik had raised the possibility of attacks from space. Then, at an American meeting with Perkis, who was a Canadian politician and soldier, was concerned that Canada could not afford defense systems against both ballistic missiles and manned bombers. He also said Canada couldn't afford the Arrow or to assist in the SAGE project, but not both. On the 11th of August 1958, Perkis requested the cancellation of the Avro Arrow, but the Cabinet Defense Committee refused. This caused more stress on the Canadian economy and government. Canada was involved in too many projects and their money was being depleted. Then, a year or two later, on the 20th of February 1959, the Arrow's cancellation was announced. The day became known as Black Friday in the Canadian aviation history. The true cause of the cancellation still remains a mystery, but Diefenbaker claimed the decision was based on the cost of the plane and the defensive systems. Though the Arrow was an expensive plane, critics of the cancellation later argued that the development could have been completed for the cost of the cancellation fees alone. Also, the Arrow program was cheaper than purchasing missiles and replacement interceptors from the United States. There is a theory surrounding the reason the Avro Arrow was cancelled. It has been a theory that the United States was threatening our government because they didn't want Canada to have better technology and air force than they did. It was thought that Diefenbaker did not have the nerve to stand up to these threats and just cancelled the Arrow. This is just a theory, however, and there is no factual proof that this took place. After the Arrow was cancelled, it put 14,528 Avro employees as well as nearly 15,000 other employees out of work. The Avro management was caught unprepared by the suddenness of the announcement by the government. The cancellation took place after a review where the Arrow Mk2 RL206 would be prepared for both an attempt at both world speed and altitude records. We may never know the full reasons for why the Arrow was cancelled, but we do know it's the day Canada gave up on a project that could have changed the history of Canada and even the whole world. 2 months after the project's cancellation, all of the aircraft engines, production tooling, and technical data were ordered to be scrapped. Sometime after a change of government, the new RCAF chief came to inspect the facilities and programs of Avro Canada. The commanding officer of the Flying Personnel Medical Establishment and Wing Commander Roy Stubbs asked him if he would like to see something special. Roy Stubbs showed him a piece of the Arrow, which was the cockpit section and engine with a few other bits. Roy asked him what he should do with it, and the RCAF chief said to keep it hidden until the climate in Ottawa was right. Then he would arrange to have it placed in the National Aviation Museum in Ottawa. Eventually this was done, and a piece of history was saved. The story of the Arrow is a sad one. If it had gone into full production, assuming the aircraft had performed as the test suggested it would, Canada would have been among a small handful of nations that could claim to have built the top line of supersonic jet fighters. There were thousands of high-tech jobs lost when the project was cancelled. The plane was a crown jewel of Canadian aircraft and even stood out in the world as the fastest jet of that time. The supersonic fighter jet could reach a speed of nearly 3 times the speed of sound, traveling at an altitude of 60,000 feet. The possibilities weren't just in the plane itself, but in the possibilities it had for the future. Even though today we have planes that can reach speeds way faster than the Arrow could have, the plane was still revolutionary for its time. If you just think we were reaching these amazing technology 70 years ago, you can only imagine the technology we could have today if the government didn't cancel the project. Today, the legacy of the Arrow is both one of pride and frustration for most Canadians.
Aircraft nowadays are maybe more sophisticated in this or that, and better engines, better fuel consumption, better pressure recoveries. But there's nothing that I know of that would, even now, today, be an improvement on that maneuverability capability.
It was absolute state-of-the-art. It was a beautiful machine, and we probably would still be flying it today.
In losing the Arrow, we lost not only a symbol of national pride, we lost the technology and an immense pool of talent.